Slightly trickier, but actually easier, is day 3. So for day 3, when we're looking at this fact, the measurement is going to show us an object. There's 2 objects to measure, the tree and the rock. So if we plant the tree, okay, and we start to measure the tree and we hit pause, you can see that the radioactive, if we start going through it, there's 100% radioactive, because as a tree is growing, it's taking in carbon dioxide, the CO2, a certain percentage of it is radioactive, and you can see that it's 100% the whole time, okay? And so since it's 100%, once the tree starts to die and stop taking in carbon dioxide, now that wood is going to start to decay, and as the wood starts to decay, you can see that the C14 is starting to go down. Okay, so as the tree dies, the tree died right here. So what snapshots do you need to take? You need to take a snapshot of the years the tree died at, which it looks like I went right past, so I need to reset it. We plant the tree, and we watch it grow. I'm going to try to pause this right when the tree's dying. So we're going to take a snapshot right here. Okay, this is we got 2 snapshots to take. Here's the percentage of carbon-14. Okay, that goes right there. How many years did it die at? Tough to tell right here, so they give you the number 1370. So if we go 1370, there's 100% carbon-14, and we've also got a snapshot that I want you to take of the graph. Okay, we can just shrink that down so it fits. And so you're going to keep going. Once there's half of the carbon-14 left, take a snapshot of both of those. So if we hit play, we're just waiting until this number gets down to 50%. You can see that it breaks down at a pretty steady rate, and it's going to be 5,700 years later. But the problem is, it didn't start decaying just here. It started, like, what was it, 1,300 years later or something? So we're not going to get down to 50% until 5,700 years after the point that the organism dies. So I'm going to try to pause right on 50% as good as I can. And that would be where 1 half-life is in. So it's 5,700 years after the point that the tree died. That tree lived a really long time, huh? 1,300 years? Seems like a long time for a tree to live. And so you would keep watching, and it's going to get down to its second half-life when you have half of 50%. Quick math, that'd be 25%. So the half-life is a steady rate. It doesn't matter how long time goes on for. It's going to be every 5,700 years for the carbon. And then you're going to reset all this, and you're going to throw a rock out there and switch to uranium-238 and let the volcano erupt. And once the volcano erupts and that rock lands there, it doesn't start until the rock cools. So once the rock actually gets cool, then you're going to have the decay start. And you can start to do that. Now that the rock's cool, the uranium starts to decay. And you take your snapshots for that. Okay? So those, hopefully straightforward enough, just to see a tree decaying and tracking the C14 of that. See the rock once it's made. You can figure out how old the rock is by, measuring the percentage of uranium-238 in that. And uranium just has a really long half-life.